What's up, Patriots? I'm glad you're here. If you've ever scrolled past a clip of a rifle that looks ripped straight out of a sci-fi shooter and wondered why civilians in the US can't own this kind of hardware, you're in the right place. Today I dig into the machines that make gun nerds salivate and lawmakers nervous. The FDML5 Multibore salvo rifle, the MP55 Ultimus smart shotgun, the Silencer Co. Maxim 9 with its integral suppressor, the TrackingPoint M900 precision-guided rifle, and more, to show you how they're built, why they work, and why they're often off-limits for civilians. I'll be blunt, I love engineering. I geek out over barrels, bolts, gas systems, and modularity. But there's a reason the National Firearms Act, 1934, and the Gun Control Act of 1968 still get quoted in ATF letters, and why the Bureau of Alcohol, Tobacco, Firearms, and Explosives, ATF, headquartered in Washington, D.C., steps in when a design crosses a legal or safety line. So I'm going to break down the design choices, the mechanical trade-offs, and the real-world implications, all in plain English, first person, and with the kind of technical detail you won't hear in a headline. If that sounds like your jam, hit subscribe and let's get into it. All right, let's start with the thing that looks like it fell out of a mecha anime, the FDML5. At first glance, the headline feature is obvious. 5 over-under bores packaged into one barrel assembly and a novel metal block magazine that feeds 5 projectiles per block. I want to focus on how that forces the entire mechanical design to rethink basic assumptions. To fire 5 rounds simultaneously, you must synchronize multiple firing pins or strikers and ensure chamber pressures and barrel harmonics don't tear the system apart. That means heavy-duty locking systems, precision head spacing for each bore, and a rigid barrel cluster to preserve accuracy. The multi-caliber idea? Different chamber pressures, gas flow behavior, and recoil vectors that all have to be balanced in the chassis. Thermal management is brutal. 5 simultaneous shots dump insane heat into a tiny volume. So material choice, high-temp steels, coatings, and cooling geometry matter. Mechanically brilliant, visually wild. But you can see why safety, controllability, and sheer stopping power make regulators nervous. This one appeals to the tinkerer in me. The Pivot, a 9mm rifle that collapses by literally swinging the top half around the bottom half. The core engineering challenge here is a load-bearing hinge that must also preserve alignment for the barrel, feed from standard Glock 19 magazines, and maintain a safe lockup under firing stress. So the hinge isn't a toy, it's an engineered joint with positive locking detents, shear-resistant pins, and often an over-center locking cam to prevent accidental folding when the trigger is pulled. Materials are a dance between strength and weight. Steel where you need rigidity at the hinge and barrel extension, aluminum for the receiver, and polymer for ergonomics. There's also the ergonomics puzzle, collapsing to about 5-inch for transport, but deploying to a 27 to 30-inch system with a collapsible stock, you must preserve sight radius, optic mounts, and suppressor threads. The hidden risk is fatigue at the pivot point and potential loosening over time. You don't want barrel misalignment because that kills accuracy and can be catastrophic. Clever, compact, but those moving interfaces demand disciplined engineering and maintenance.
Now, let's nerd out on electronics meeting ballistics, the MP55 Ultima, a shotgun with an onboard computer, a small screen in the buttstock, Wi-Fi/Bluetooth, GPS, and a barrel-mounted camera. Integrating electronics into a firearm isn't just slapping a PCB in a cavity. It forces you to reconcile shock, recoil, ingress protection, EMI, and battery placement with traditional structural requirements. For example, the buttstock must house the battery pack and processor, but still transfer recoil into the shoulder. That means shock-isolated mounting for the electronics and careful routing so wiring doesn't weaken the stock. The barrel camera introduces thermal and vibration issues. You need rugged connectors and vibration-damping mounts so the sensor survives sustained fire. Then there's power and heat. Lithium cells and processors generate heat that, if unmanaged, shorten component life. So thermal paths, ventilation, or heat sinks are deliberate design choices. Finally, software implications, logging shots, GPS tagging, live video, change the risk profile. Privacy, data security, and remote access vulnerabilities become engineering problems as much as legal ones. It's brilliant engineering, and it forces a whole new checklist for safety and regulation.
Look, I love clever engineering as much as the next gear nerd, but this tour through the ridiculous and the remarkable proves a point. Innovation without purpose is just expensive theater. We saw shoulder-mountable cannons that belong on a movie set, dual-barrel pistols built for Instagram, and smart shotguns that will die with your battery. We also saw real, purposeful advances, modular precision from Desert Tech, extreme reach from Barrett, and the quiet, efficient genius of the VSS family. That contrast is everything. If you ask me where we should be putting our attention and money, I'll always bet on reliability, maintainability, and mission fit over gimmicks. Tech that augments human skill, great. Tech that replaces judgment and then misbehaves when the power flickers, dangerous. I want engineers solving real problems, easier logistics, safer designs, and tools that actually help people survive and operate, not just headline-grabbing prototypes. So tell me, which of these guns would you actually trust in a real situation, and which ones belong in a museum display case? Drop your picks and why in the comments. I read them. If you liked the deep dive, hit like and subscribe. And if you want more takedowns like this, say so down below. See you in the next one, and as always, hold 'em down. This rifle is an engineering love letter to modularity. The SRS A1 squeezes full-length precision into a short bullpup package by using a telescoping bolt and a chassis that's deliberately designed to accept rapid barrel and bolt swaps. From a design perspective, the clever bits are how the bolt head, barrel extension, and head spacing surfaces mate precisely after a swap, how the receiver tolerances keep concentricity so you don't lose POI, point of impact, and how the rail geometry preserves optic alignment across calibers. Thermal and recoil characteristics change massively between a 308 and a 338 Norma, so the stock, bedding, and recoil path need to be optimized for the entire family, not a single cartridge. The SRS's modular locking system and torque wrench changeable components show real attention to repeatable precision, but they also raise maintenance demands. A sloppy swap ruins accuracy or can cause catastrophic pressure issues. I love the concept, compact, adaptable, and surgically precise, but it's a platform that requires a competent user and careful inspection every time you change calibers. Okay, this one is pure ridiculous engineering theater. Two M1911 barrels side by side built into one frame. The first thing that stands out from a mechanical design view is managing recoil impulse and timing across two parallel firing circuits. You need dual sears or hammers or linked triggers, a single slide that travels smoothly over two barrels, and a frame strong enough to take the combined forces without flexing. Heat management is also non-trivial. Two .45 ACP rounds in rapid succession create concentrated heat across the slide and barrel hood. Metallurgy and surface treatments matter. Another subtle issue is how the grip geometry and mainspring housing are adapted so the shooter can control muzzle flip. Otherwise, it's just a punchy, embarrassing handful. From an accuracy standpoint, aligning two bores so both remain point of aim and point of impact under recoil is a tiny miracle of machining. It's a cool collector's piece and a demonstration of gunsmith creativity, but for practical or defensive use, it's inefficient and introduces failure modes you'd rather not have in a primary sidearm. When you talk about a rifle that fires a 20mm Vulcan-style projectile, you're in a whole different engineering class. The Anzio 20mm is basically a precision artillery piece in rifle form. Massive chamber pressures, enormous bore wear, and ballistic energy that demands an overbuilt receiver, match-grade rifling, and aggressive muzzle brakes. Key design problems here are materials that resist erosion from the huge propellant gas temp and pressure, and a bolt and lockup system that prevents case rupture under extreme stress. Barrel contour and thermal mass are deliberate. You want stiffness for accuracy, but enough thermal capacity so the barrel doesn't warp after a few shots. Recoil management is its own discipline. Muzzle brakes, massive mass, and often vehicle or tripod mounting are non-negotiable. You also redesigned feeding entirely. Magazines and feed geometry for that cartridge are bespoke. From the perspective of civilian ownership, the engineering is fascinating, but the platform's destructive potential and operational needs, logistics, range, mounts, put it squarely into military or collector territory rather than practical civilian use. This little weirdo is a great exercise in compromise engineering. The SR410 takes the revolver form factor and stuffs shotgun capability into it. That means a rotary cylinder designed to handle shot shell pressures, along with chambers that must seal reliably despite the short, fat cases. From a design standpoint, the tricky bits are head spacing and cylinder gap control. You want minimal leakage for velocity, but you also need tolerance so the cylinder rotates cleanly under recoil and fouling.
Barrel options, smooth versus rifled, change everything. A rifled cylinder and barrel lets you shoot slug-style projectiles more accurately, but the rifling and choke geometry must be balanced to avoid excess pressure spikes with certain loads. Weight distribution is critical here. Make it too heavy and it's clumsy. Make it too light and recoil becomes punishing. Finally, sealing and extraction solutions for spent shot shells are non-trivial because primers and skirted cases behave differently than pistol cartridges. It's clever and compact, great for novelty and backpack carry, but engineers designing it are constantly juggling tolerances, materials, and ergonomics to keep it safe and practical.
The Tavor 7 is a masterclass in packaging high-power performance into a short footprint. Bullpup layouts force you to rethink ejection, charging, and control placement, and Tavor's solution is modular ambidexterity. The ejection port and charging handle can be changed so lefties aren't left out. Mechanically, that means the receiver has interchangeable bolt/ejection assemblies and robust tolerances to keep reliable extraction across positions. Feeding a 7.62 round in a compact chassis also requires a stout, short-stroke gas piston that can be tuned for different ammo types, hence multi-position gas settings for regular, suppressor, and adverse conditions. The recoil impulse path is routed straight into the shoulder rather than the wrist, so stock geometry, cheek weld, and buffer systems are tuned to manage higher momentum. Material selection focuses on high-strength polymers for the lower ergonomics and steel aluminum where chamber stresses concentrate. For me, the elegance is in solving user-centric problems, ambidexterity, compactness, without sacrificing the mechanical robustness needed for full-power cartridges. Integrating a suppressor into a pistol chassis changes the entire engineering playbook. The Maxim 9 wraps the suppressor baffles around the barrel, so you now design the barrel/suppressor as a single thermal and pressure system rather than separate components. That has direct consequences. Pressure curves change. Back pressure can affect cycling and OAL, overall length, management. And the baffle geometry must be serviceable for cleaning while remaining rigid under heat. To make it practical, designers used modular baffles that can be removed to shorten length or for maintenance, and they had to address how swept-back gas affects the slide and extractor. Material choice is again crucial. High-temp alloys, corrosion-resistant treatments and coatings for baffles keep erosion in check. Also, the suppressor's thermal mass alters point of impact during extended strings of fire, so the barrel's harmonics and crown design are tuned to compensate. From an engineering point of view, it's brilliant, integrated, stealthy, and neat, but it also creates regulatory headaches because integrated suppressors are treated differently under law in many jurisdictions. I like to close with these two because they represent two divergent engineering philosophies. TrackingPoint M900 is about augmenting human aim with sensors and computation, target lock, laser range finding, ballistic calculators, and a trigger-linked fire control that compensates for user error. Engineering it means marrying ruggedized electronics, low-latency sensors, and mechanical interfaces in a recoil-harsh environment. Mounting points must isolate shock from IMUs. Power systems have to be compact and hot swap capable, and firmware must be deterministic under all conditions. Contrast that with the Barrett MRA ELR, which pursues accuracy by brute mechanical means. Massive match-grade barrels, heavy contours for stiffness, adjustable buttstock geometry, even motorized adjustments on some variants, and hardware built to swallow enormous pressures and long-range transients. The MRA's modularity, swap bolt heads, barrels, is a machining puzzle. Repeatable head spacing and concentricity across components is a tiny miracle. Together, they tell a story. Do you augment the shooter with sensors, or do you design the rifle so accurately that shooter variance matters less? Both are engineering feats, and both force us to ask where technology crosses into things regulators feel the need to control.
All right, quick recap. I went through a handful of weapons that look like they belong in a sci-fi arsenal. From the FDML5's multi-bore mechanics to the Pivot's folding engineering, the MP55's onboard electronics, Desert Tech's modular sniper choreography, the AF2111A's double-barrel theatrics, and the brute force of the Anzio 20mm and ELR platforms. What ties them together isn't just raw power, it's design decisions. how the lockup is built, how heat and pressure are managed, how moving interfaces tolerate fatigue, and how electronics are integrated without becoming liabilities. Those are the reasons engineers geek out and regulators step in. I love this stuff because it shows the edge of human problem solving, but I'm also realistic. Great engineering doesn't erase responsibility. Some of these designs are best left to labs, militaries, or careful collectors. So tell me, which design surprised you the most and why? Drop your thoughts in the comments, hit subscribe if you dug the deep dive, and share the video with a mate who loves nerding out over barrels and bolts. See you in the next one, and as always, hold 'em down.